Hello everyone. Today we are going to be going over lesson 2.3 right here, and it says understand proportional relationships, equivalent ratios. So today we're going to be talking about proportional relationships and how it has to do with equivalent ratios. Last time we talked about fractions, the other time we talked about unit rates, so now we're going to talk about equivalent ratios, and we've kind of been already doing some of that. So today should be an easy day. So page 10 through 13 is where this is at, and you can say I can test for equivalent ratios to decide whether quantities are in a proportional relationship. So that is what you should be able to do at the end of this lesson. Let's go. So we're on page, hold on, sorry about that. So we are on page 10. So the warm-up is on there. We are going to skip past the warm-up because you are going to do that in class, and then we're going to go straight to example 1. Oops, sorry guys. So I know yours is a little dark, but we're going to still try and work on it. So I'm going to move this up here because we don't need the first example. Did it again. All right, on Sarah's favorite mobile game, she is awarded game lives when she finds gold coins. How is the number of game lives awarded related to the number of gold coins found? So as we can see, let's ask ourselves, how can you describe the relationship between the number of coins and the number of game lives? Well, if we look here, we can see at 1 coin, she got 3 game lives. And we got 1 coin here, she got 3, and 1 coin here, she got 3. And it looks like every time she gets a coin, she gets 3 game lives. So we're going to say for every coin, she gets 3 game lives. So for every coin, we're going to put on top, we're going to put lives on the bottom. So for every 1 coin, she gets 3 game lives. And if we make a table, we can see that. So we're going to put the coins on the top of our table and the lives on the bottom. And we're going to say, well, 1 to 3. So we look like when she had 3 coins, she had 9 game lives. When she had 2 coins, she had 6 game lives. And when she had 5 coins, she had 15 game lives. So we need to make sure that each time it's going to get that 1/3 ratio. So if we divide 3 by 3 and 9 by 3, we end up with 1/3. If I divide this by 2 and this by 2, I end up with 1/3. And if I divide this by 5 and this by 5, I end up with 1/3. So because they all ended up being 1/3, that means they are equivalent ratios. They all end up being that 1/3 ratio. So this is how we know that this is proportional. So how is the number of game lives awarded related to the number of gold coins? For every 1 coin, she receives 3 lives. And that's your answer right there. So this is where we get those equivalent ratios, and this is how we can check if a relationship's proportional. It has to be, a relationship has to be equivalent. The ratios have to be equivalent in order for it to be a proportional relationship. So let's go fill out our vocabulary on page 11. It says blank quantities are in a blank blank if all the blank that relates to the quantities are equivalent. So based on what we know, we're going to say 2 quantities are in a proportional relationship if all the ratios that relate the quantities are equivalent. And again, we just saw that in this last one. 3/9 is equivalent to 1/3. 2/6 is equivalent to 1/3, and 5/15 was equivalent to 1/3. So they were all equivalent. So that's how our vocabulary for that one. Now we're going to go on to lesson 2.3, example 2. So it says, is the relationship between the area and the side length of the squares proportional? Explain your reasoning. So first, let's write the side lengths of all of them. We have the inches, side length in inches. So we have 2, we have 3, and we have 4. And they use X to represent that. So our first step asks us to make a table to organize data and then find the ratios that are equivalent. So we're going to put our y over our x over here and see if they are going to make equivalent ratios. So we have 2 for all our side, 3 and 4 for all our side lengths, and then our areas, well, we're going to have to figure that out. To figure out the area, we're going to take our base times our height. Base times height. Well, our base is 2 and our height is 2, so it's 2 times 2, which gives us 4, 3 times 3, which gives us 9, and 4 times 4, which gives us 16. And if you missed that, that's 2 times 2, 3 times 3, and 4 times 4. And that's how we got our answers. And so now we're going to take our area y and put it over our side length x. So we have 4 over 2, and we need to simplify that. They both can be divided by 2, which gives us 2 over 1. Then we have our 9 over 3. They can be simplified. We're going to divide both by 3, and we get 3 over 1. And over here we have our 16 over 4, which gives us divide by 4, divide by 4, and you're left with 4 over 1. So we need to compare our ratios. We have 2 over 1, and 3 over 1, and 4 over 1. As we can see, they all have 1 on the bottom, but our tops don't match. So these are not equivalent, which makes this not proportional. So going back to our original question, is the relationship between the area of side lengths and the squares proportional? No, because they are not equivalent ratios. And so again, when we put our y over our x or our area over our side length, all of these should have been the same ratio. If they are not the same ratio, and when we simplify them, that means they are not equivalent, like we saw on example 1. So we're going to fill in this vocab really quickly, and then tomorrow we will start on example 3. So a blank is an equation that represents equal ratios. So a proportion is an equation that represents equal ratios. And we will talk more about that. This is something we know. A proportion is just something related to something else. We would look at it like this, and we've been doing it this whole time. Something equals something else. And those are those equivalent ratios. They have a proportional relationship. So we will talk more about that tomorrow when we do our warm-up. When we go over our example. If you have any questions, please let me know, and on Canvas or in email. And you guys, I will see you later. Bye, guys.